Excuse me, sir. I have a doubt, sir.
Sir, you are not audible.
Am I audible now? Am I audible,
Yes,
Abhishek
sir. Yeah.
Gupta? Okay, okay. Actually, since for the first time I am taking the class in college machine, so probably I have missed clicking a particular button. Uh, I think I'm audible now, isn't it?
Yes, sir. You're right.
Okay, so I was what I was telling is that in the previous session I discussed about discrete random variable, which is having a probability distribution, and in the probability distribution, the individual probabilities are probability mass functions. We denoted the probability mass functions by this particular symbol, p of x equal to small x, and these particular probabilities are greater than or equal to 0, and total probability is 1. And I was saying that in some books, in authors use different notations to represent the probabilities. So in some books, you may come across the probabilities denoted by small p of x greater than or equal to 0 and summation over x small px equal to 1. But I actually prefer the notation which I have ticked over here because it is more explicit. Also in the previous session, we calculated the mean of the random variable, which is called the expectation of the random variable denoted by ex. Why it is called mean is because my arithmetic means formula for the frequency chart is actually given by this, where each value is multiplied by their respective frequency. Now, if I replace all the frequencies, if I replace all the frequencies all the frequencies by probabilities, then what do I get? I will get P1 x1, P's are my probabilities, P2 x2 plus Pn xn, and divided by P1 plus P2 plus dot 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 Pn. But you know the total probability is always equal to 1. So we will be left with only the numerator term, which is this. Immediately after, and therefore it is arithmetic mean. Therefore it is arithmetic mean. Okay. And it it has another interesting scenario. I'll tell you very briefly, and you will see that in this particular case, the random variable is having an arithmetic mean. So after seeing this, the mathematicians quickly defined the expectation of the random variable in the following manner. So for discrete case, this expectation is actually defined as take the summation over the term, x into probability of small x and consider all possible values of x. This is the formula, general formula of calculating arithmetic mean EX. This is the general formula of calculating arithmetic mean EX. Now, remember that this EX, which is actually, if I write it explicitly for finite number of terms, which is this one, P1 x1 plus P2 x2 plus dot 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 plus Pn xn, is associated with two more properties. One property is each Pi is greater than or equal to 0, and summation Pi is equal to 1. Okay, such a thing, if happens, is actually said in a following way. We can say, therefore, we can say that this EX is actually a convex combination, is actually a convex combination of the outcomes x1, x2, dot 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 xn. It's a kind of convex combination. Okay, but suppose for the time being, suppose the formula of Ex is like this: P1 x1 plus dot 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 plus Pn xn, but these conditions are not there. I'm writing up to this only. Okay, I'm not saying that Pi is greater than or equal to 0 and summation Pi equal to 1. In that case, if it happened, then we could have said that Ex is a linear combination of the outcomes x1 dot 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 xn. So this is the difference between the linear combination and the convex combination. And keep this in mind because it will be required in my subsequent lectures somewhere at some point of time. So this is the thing. And so we have calculated the probability chart. Remember that the outline of the probability chart, probability distribution, is not that you have to tabulate all the possible outcomes, because that is the sample space. What you need to do is that you define a random variable, and according to the random variable, you are going to get some values. Okay, those values you keep in the chart and their respective probabilities, that will define your probability distribution. You don't have to tabulate all the random variables. Okay, now the calculation of expectation is not only the thing that we do with the probability distribution chart. Tomorrow in my class, which is at, I think, at 8:40, if I'm not wrong, in the morning, I'm going to discuss something else. I'm going to do something else on my probability distribution, probability chart. And that will give us the complete description of how to deal with the particular probability distribution, whether the variable is discrete or continuous. Remember one thing, that similar sort of definition will come across in continuous case also, but a little bit of change will be there. Now, can anyone say, just a guess, before I conclude my today's session, suppose I am writing that capital X is continuous. We do not have any idea about continuous. I have not discussed continuous case over here. Okay, can you guess? I'm just asking you, can you guess? Someone unmute yourself and tell me, can you guess what will be the formula for expectation of X in case of continuous case? What will be the change in the given formula? Any idea? Anybody? You can write in the chat box also directly. No, acha, okay. How do we represent summation in case of continuous case?
Sir, integration
Yeah, very good. So we will consider the integration over all possible x, and the rest of the thing will remain same. That is the thing. Rest of the thing will remain same. So that will be discussed in our class when I will be discussing the continuous distribution, continuous random variable. We will now for some time we will be before our continuous assessment test happens, we'll stick to discrete random variable case only. Okay. So with this, I'm going to conclude my today's session. Hope you I am able to convey my uh, I mean I'm able to convey what am I supposed to talk about in my today's class. And one last thing, that in Google Classroom I have actually uploaded one handwritten note by me, which is actually giving you which will actually give you the idea about the mathematical idea about the probability space. Probability space was discussed in my first class from a pedagogical point of view, but that was not the mathematical approach. For mathematical approach, you can go through my handwritten note. Also, I have uploaded a book, but I'll not suggest to go. I'll not ask any student to read the entire book. It is not feasible. Okay, so I'm actually preparing a note and my personal note. Very soon you are going to get the notes of some which will contain something else which has not been discussed in the class. A conditional probability note, if you are getting, you will see in the note that some other different problems will be there, and which is different from what I discussed in the classroom. So I am doing it in a manner because so that the variety of problems you actually deal. Okay, if I discuss a particular problem and if I write the same problem in my note, then the variety will not be there. Okay, so I'm very soon you are going to get a note for each module that I finished so far, and keep watching my YouTube video, subscribe to my channel, and you'll get the notification. And I will also upload my today's class in my YouTube channel. So don't worry. Try to keep the attendance above 50. Okay, that is the criteria. So with this, I'm going to conclude my today's session. Thank you so much for joining. You can leave the classroom.